Hello, good day, viewers. Still on WAEC 2024 Mathematics Examination Objective Questions. Today we are going to begin with question number 11 down to question number 15. And question number 11 reads, an interior angle of a regular polygon is 168 degrees. We're asked to find the number of sides of that polygon. All right, let us understand something here. When a polygon is said to be regular, is if and only if all its interior angles are equal. So every single angle in that polygon will have to be 168 degrees. And remember, if you want to find the sum of all the interior angles of any kind of polygon, you can take n minus 2, then you multiply by 180 degrees. For example, if you are dealing with a triangle that has 3 angles and 3 sides, remember that the sum of all its interior angles equals 180 degrees. So where n is 3 for triangle, 3 minus 2 will give us 1, and 1 times 180 is still 180. But in this case, we don't know the number of angles. So since we know that every single angle equals 168, we can divide this by n. N stands for the number of angles or sides, and this must give us 168 degrees. So from here we can cross multiply and expand the bracket. 180 times n will give us 180 n. 180 times negative 2 will give us negative 360, and this is equal to 168 n. I just decided to move on without assigning degrees because in the end we are looking for a number of sides, not degrees. All right, let us collect the like terms. You can take this one to the other side and bring this one backward. So we have 180n minus 168n, and this is equal to 360 degrees. And 180 minus 168 will give us 12. So we have 12n equals 360, and n equals 360 divided by 12, and finally n equals 30, and hence that polygon has 30 sides. And this is question number 11. Now let us move on to question number 12. If 3x minus 2y is equal to negative 5 and x plus 2y equals 9, we're asked to evaluate x minus y divided by x plus y. First of all, I would like to solve for x and y from this particular system of equation. Let me call this one 1 and call this one equation number 2. I would like to add equation 1 and equation 2 together. So we have 3x minus 2y equals negative 5, and we have x plus 2y equals positive 9. Remember, we are adding. So this plus this will give us 4x's. This plus this will give us 0. We move to the right. This plus this will give us positive 4. Then as you divide both sides by 4, you have x to be equal to 1. If x equal to 1, what will be the value of y? We can plug it into either this equation or this equation. I would like to take equation number 2, where x is 1. So plugging it here, we have 1 plus 2y equals 9. If you take 1 to the other side, it becomes negative. So 2y equals 9 minus 1, which is 8. Divide both sides by 2, you have y to be equal to 4. And hence the value of y is equal to 4. But remember, what we are asked to evaluate is x minus y divided by x plus y exactly. But we have seen that x is 1 minus y is 4, 1 plus 4, and 1 minus 4 is negative 3, and 1 plus 4 is 5, and hence the solution to this problem is negative 3 over 5. That's question number 12. Let us move on to question number 13. Question number 13 reads, a variable w varies partly as m, and partly inversely as P. Which of the following correctly represent the relation with K1 and K2 as constants? We have A, B, C, D here as options. Well, look at the question carefully. W, which is given as the dependent variable, is equal to what? It varies partly as M. But remember, since we are talking about variation, you have to attach that constant of proportionality. So the first constant is K1, and it is directly proportional to M. So we have M here. And partly inversely, so it is inversely proportional to P, right? Yeah, you can see that here, inversely proportional. Then you attach your second constant to the top, that is K2, which I think is option C right here. Now let us move on to question number 14. Question number 14 reads, a cylindrical metallic barrel of height 2.5 meter and radius 0.245 meter is closed at one end. We're asked to find, correct to one decimal place, the total surface area of the barrel. Okay, let us construct it. Suppose we have something like this. Something like this. Let's assume this is the open surface. The radius is what? 0.245. 0.245. And the height is 2.5. So the curved surface area is given as what? 2 pi RH. That's the area of the curved surface. Then plus one of the cycles, because one is already open. So the total surface area will be area of cycle, which is pi r squared, then plus the curved surface area, which is 2 pi r h. I think we have pi and r in common. So pi r inside, from this one we have a single r left, and this are already gone, so we have 2h. Then we can substitute. Remember, they say we should take pi as 22 divided by 7. So this is equal to 22 divided by 7 multiplied by r, which is 0.245. Then multiply by another radius 0.245 plus 2 multiplied by h, which is 2.5. This is what we need to simplify. 22 divided by 7 multiplied by 0.245 will give us 0.77. Then we multiplied by, we can take 2 and multiply by 2.5, which is exactly this one. That will give us 5, and if you add 5 to this, that will be 5.245. So all you have to do is to multiply these two together, and if you do that, you're going to get 4.03865 meters squared. But remember, they said in one decimal place, so this is equal to 4.0 meters squared in one decimal place. And this is just the answer to this problem. Now let us move on to question number 15. Question number 15, we are asked to make capital R the subject of the relation V equal to pi L multiplied by R squared minus small r squared. All right, our main goal is on this R. So we first of all divide both sides by pi L. So we have V divided by pi L. This is equal to R squared minus R squared. Then we can take this one to the left. As we take it to the left, it becomes positive. We have V divided by pi L, then plus R squared equals capital R squared. We want to make R the subject, therefore we can take square root of both sides. Take square root of this and take square root of the other side. This will cancel this, leaving only R equals the square root of v divided by pi l plus r squared. It's supposed to be plus or minus since we have taken the square root of both sides. But I've realized from the question paper, we do not have this from the option. So if you see this one, it is the correct answer. But for me, I know there must be plus or minus here. And this is question number 15. In our next class, we are going to begin with question number 16 down to question number 20. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.